Next adhesive is the cellulose adhesive. Now we know that up to 3/4 of the dry weight of plants is mainly made up of polysaccharides, and which are those polysaccharides? They are cellulose, gums and starch. And out of these, cellulose is the structural material, the main structural material in the cell wall of all the plants, and you can also find it in other organisms like algae, bacteria and tunicates. It is basically a homopolymer of beta D glucopyranose monomeric units. This is the structure for the monomeric units. Beta D anhydroglucopyranose units, and the carbon atoms as labeled in this figure 1 2 3 4 5 6, as you can see, these are the carbon atoms labeled for one monomeric unit. Now when such similar monomeric units, they come and join to form the polymeric chain, the linkage basically happens between carbon 1 of one unit and carbon 4 of the adjacent unit. So in a way, every monomeric unit is rotated to 180 degrees approximately about the long axis of cellulosic chain when you compare it with its two neighboring units, as you can see in this structure above. So the chain length in cellulose actually ranges from 700 to 25,000 glucose units. Now, due to the presence of large number of OH or the hydroxyl groups, as you can see in the figure also, in the structure, one monomeric unit has almost three. So large number of OH groups are present and give rise to a highly crystalline structure. Now, since the hydrogen bonding between the cellulosic molecules is not easy to disrupt, to break, we say that cellulose itself is not so useful as an adhesive. Why? Because the hydrogen bonding present in the cellulose molecules is not easy to break up, due to which the cellulose does not dissolve in most of the common solvents. So the solution to it is that we do not use cellulose as such, but we can convert it, of course, to many of its derivatives that can be used in formulation of adhesives. There are certain modifications of cellulose which are done, and one of the most important factor while describing such molecules is the degree of substitution, or the DS value. The DS value should be specified for the derivatives of cellulose, because that will tell us the nature of those derivatives, because the properties of the derivative basically depend almost as much on the DS, or the degree of substitution, as they do upon the substituting agent. So commonly observed DS value is 1 and 2, and sometimes, rarely, we can get a value of 3 also, but which is a difficult target to achieve. So let's see what are the modifications which can be done. Esterification. Esterification of cellulose can be done to get cellulose trinitrate form also. So let's see these reactions. The first chemical reaction actually involves the nitration of the cellulose using the nitric acid. Now in this particular reaction, you can see that all the OH groups in the reactant, when subjected to nitration in the presence of nitric acid and sulfuric acid in the aqueous medium, or with a little amount of water, then what happens? All these functional groups, they get replaced by ONO2. In other words, you can say that the nitro group, NO2 group, comes and replaces the hydrogen in the cellulose, and that's the easy way to remember. So this is the nitration process. The second equation actually explains the esterification of the cellulose. Now how do we do esterification? The reagent that we use is the acetic anhydride, CH3CO whole twice O. Okay. So acetic anhydride is taken, and in the presence of sulfuric acid and water, this esterification is carried out. Here again, the H of all the OH present in the cellulose, it gets replaced by COCH3. So the acetic or the acetyl group comes and sits in place of H, and we get CH2O, COCH3 in all the places wherein H is present in the cellulose. This is, remember, this is only the one of the monomeric unit that has been taken over here, reflected for an example. And with this we get acetic acid, 3 molecules of acetic acid. The third is the hydrolysis of the cellulose derivative, wherein the acetate or the cellulose acetate has been taken. It is subjected to hydrolysis and done in the presence of HCl. Okay, so we get the final product over here, and the hydrolysis is carried out. So these are basically a few of the reactions of the modification of cellulose. Just for the example's sake, we have mentioned over here. Let's see what are those derivatives which we talk about for the sake of adhesives. The number one is the cellulose nitrate. Now cellulose nitrate is basically used in lacquers, plastics, coatings, along with the adhesives. So besides adhesives also, it has various uses in plastics, in lacquers and coatings also. But if we discuss the cellulose nitrate as an adhesive, it is used in the household cement with the nitrate and a plasticizer commonly dissolved in a ketone ester, which is an organic solvent. So it's a mixed solvent, ketone ester solvent, and yes, of course, an organic solvent. So when applied on the substrate, the solution loses the solvent molecule rapidly, and during the process, when it loses the solvent molecules, it becomes tough, it becomes hard and moisture resistant, and a clear film is formed on the surface. So that's all about the cellulose nitrate. Next is our cellulose acetate butyrate. Cellulose acetate as an adhesive has some limitations, due to which we have to convert the cellulose acetate into another derivative form, that is a butyrate. And the use of mixed ether cellulose acetate butyrate helps in overcoming those limitations or the difficulties associated with usually the cellulose acetate as an adhesive. So it is more compatible with the common plasticizers, and it can be applied either as a dissolved in the solvent or as hot melt adhesive, which is an important feature of this acetate butyrate, that it can be applied as a hot melt adhesive also. Next is our carboxymethyl cellulose. Now CMC, or the carboxymethyl cellulose, in its sodium salt form, it is used widely. It is the widely used cellulose ether. Yes, of course, it is water soluble, but it was originally used as a replacement of natural gums in adhesives. It's no longer being used as an adhesive per se. It is still used in adhesive as a thickener. So not as an adhesive, but yes, of course, as a thickener in adhesives. Last of all is our hydroxymethyl cellulose, which is soluble in hot as well as cold water. So you can prepare an easy paste out of it. And it is used in adhesive for the wallpapers, the plywoods, and the billboards, as if MS value is greater than 2.3 to 2.6, and then it is soluble in organic solvent. But if the value is lesser than 2.3 to 2.6, it is not soluble in the organic solvent. So these are the few derivatives of the cellulose which can be used in adhesives.